um, I would like to thank everybody for joining us today. My name is Yorgos Plevrakis. I represent MAN Diesel and Turbo for this session. I will be joining by my colleague George Drossos. We both are in charge of the new building and marine sector, and we are going to be talking to you about several technologies that we have developed, mainly on the actuator and on the two-stroke side. I'd like to do a few companies, so as the presentation beyond. So, as I already told you, and the opportunity myself, and I am the head of the in the local office here, and in charge of several activities on the new building side, where my colleague George give you an overview of who we are as a company. I will not take too much of it. It's just getting to know each other and introducing us. So, just to the chase, we are Diesel and Turbo SE. We are going to be overviewing our activities here in the local office, here in Greece. We are going to be introducing to you the most activities in the local office, which is actually the Prime Service Academy in Piraeus. And you will get to know each and every one of us through a couple of slides of presentation to you what we do and who. So, as probably you know, MAN is part of the greater Volkswagen Group. MAN joined the company a couple of years ago, and now we are full Volkswagen for this whole. MAN is actually is a summary with some changes. Now, we start from see that MAN is holding company, the name of the group, which two activities. Also, big part of the power engineering. The vehicles part comprised of trucks and Latin America. The main builder trucks and for the Latin America market. And on the other side, you have the power engineering, where we are actually working the diesel and turbo, and our gearbox designer and manufacturer. The recent development is that the commercial vehicles part has been now in a subsidiary of Volkswagen named Bus, and it's now the company Scania, and they Bus company inside the Volkswagen Group. So today we're talking diesel and turbo. So let's see more about diesel and turbo. M-MAN Diesel and Turbo has, it's more or less a group of its own. It was created through a merger between M-MAN Diesel and M-MAN Turbo, which almost 10 years ago. We have a logo, we have the arch you see in your screens, and we also have several other brands, with one of the most major, the biggest, namely the PrimeServe, which is actually our activities, and several sub-brands that have been very, very successful in the market. Just to give you an impression and an idea of where we start and where the diesel side is concerned, we start with engines that have an output of 450 kilowatt, four-stroke engines, and as far as the engines are concerned, again, I underline, our biggest engine is 87,000 kilowatts. This is a two-stroke engine. Where do you find MAN? Well, actually, MAN is its two sister companies, MAN Diesel and MAN Turbo. You find products from the sea to the heavy industry to refineries, from short shipping to deep sea shipping to oil and gas rigs, to refineries, to plastic industries. We are actually a power technology designer producer. As such, we the heavy industry in all of its functions. So just on your right hand, you can see a number of examples where we have our equipment. So this was a rough idea of who is MAN, who is MAN Diesel and Turbo, and I will be giving you what we do here in Greece and what are the activities that we undertake from Greece, which is a local subsidiary of MAN. As a Greek subsidiary of MAN, we are actually for all of its activities. We have our sales team and our technical team set up to present our major as a MAN Turbo pillars, which are the engine and systems, where we take sales and PrimeServe, which is probably the biggest contributor here in Greece. Prime, but we'll be briefly talking to you about that in a couple of moments. We have started establishing a tech and also we actually recognition more or less from a local team of engineers here. Second is the power plant. The power plants pillar, where we do new sales production. We take care of the service, which is again remind me our after sales. Please. And last but not least, machinery, which is at the MAN Turbo. Back to the result between diesel and turbo is the offspring of the MAN Turbo side, and we are all representing that side as well here in Greece. Academy in Piraeus, this is something that we are very proud of, and we started this and almost participants receive a certificate of attendance, so that they have received of the training and the specific equipment. To you about equipment, what kind of equipment do we serve as trainers here in the local hub? Well, as far as two-stroke is concerned, more or less, it is free to ME. We do alpha lubricators, which are the similar lubricator system of the two-stroke engines. We have diesel generators, we have turbocharger trainings, and we have trainings as well on the diesel generator side with the marine. The infrastructure, the local can host up to 60 participants, and we also be on board in the training road for our customers. This has built up for us the customers, not only the technical trainings from the interaction that we get and the information that we get from the customers, we managed to build a very comprehensive and very extensive technical library, I may put it that way, through which we can offer also technical consulting to our participants. Having said exactly what I have explained to you earlier, is the two-stroke engines that we deliver as courses locally. On the four-stroke and turbocharger, still as far as the four-stroke is concerned, from 2330 to 2830 engines, we plan even for bigger engines, but and as far as the turbocharger is concerned, we deliver the full courses. As for the benefit of the user, just to cut a long short, we have put a lot of electronic engines out there. Who will see what an electronic engine is like? The next presentation, having built a fleet of electronic engines out there, need of training in order for operators and the crews to achieve the required familiarity with this new equipment. So the biggest benefit out of that is that the crew can learn and can be trained in the operation of these engines. I will just go through that very briefly. This is an organizational diagram of people here in Greece. If you look on the right-hand side, you will see myself and my colleague George Ross, who will be giving you the presentation today. Some names. You see people that are in the local mine. Myself, we are in New Zealand from the department. So, more or less, this production, who we are doing in the local market, and I will ask for the next presentation. This presentation consists of two parts. In the first part, you will get notes on CNC needs and the NC regular two-stroke engine, an electronic one, ME, and the second part is actually going further to the development of the alternatives MEG gas fuel engine, and several aspects that are bound. So this is the one. No. So I will be handing the presentation over to my colleague, and I will be talking to you.
A very good day for me. My name is George. I'm in the office. I'm head of sales and marine and research. Here we give more about the book that we have in technical issues. The control. I'm start with the. This is the. Yeah. We'll give highlights first. Presentation. I will give you MDT highlights of 2000 about what we have within the team. Second, where the end and what is the all eight of the mechanical and the enemy of electronics. The design update is what a part of what change how it's engine two. If you talk about LGI, which is for LG, and LGI, which is for LP, and the new steps that we are now advocating on the engines, and the end also share and on the delivery of the first vessel, the an LNG-powered container vessel of 3,100 U that is built in NASCO in the United States under the Jones Act scheme. This has main engine, fully electronic, long. We will come to this about the engine. 71 ME 8G. This is gas engine, which is LNG. This is also part with 3 times 928 which dual from conventional buildings. Second one with the twin installation of flight still C9 GRD. The fuel engine, you can see the fuel type, the sign of the order is marine natural gas. It is fully fuel engine, and it is nice. Further, we have had the shock test of the engine and any LP. This carrier and the skill within 250. The fuel, gasoil, and we had, except of the main engines, we also have the propellers. We also have our own propellers, the propeller, fixed propeller with the low right hand slide. We have had the biggest, at this point, large that has been built in China. We have delivered this propeller MEC to get an electronic engine. Further, on the couple propellers, to the couplers, just about information that the alpha diesel, our belongs to in fact, the north part of Denmark has been making propulsion 110 were fixed, controllable propellers. Now into the fixed to the big tanks, the other big commercial vessels. So we have solar that they have got new 58, 500 deadweight. And we have our electronic, but we have seen with a couple of big and also have, going back again to the EGI, I said earlier, we also have a retrofit project that has been completed a couple weeks ago. This has been the night project. This is a series of that they have two 50 missions, and it has been retrofitted for MEGI. We of it, of course, make a specific on the MEGI engines. The new program, it's a little nowadays we have the tier. It has become the designation of the engines a little bit too long, I can say, but nevertheless, when you see our program for the stroke engines, then the number of cylinders. At this point, we have NS9 GI. We will say about that. It is. So the bore ratio, it is S and G. This is the G which is very low stroke, and the S is super low stroke. I mean, about 2.5 meters and 2.7 meters of stroke on the end. 9 stands for diameter, as you see, and mean nothing. It stands for electronic engine, stands for we said, and we saw any engines have nine number, which whenever it is the horsepower, we use the engine. The fuel injection constant. The next, if it's a 9, then it would be only fuel oil operating. If it is DI notation, then it is which is FG. If it is IE, it is gas ethane. If it is FI, it is liquid injection. PG. So you see we all that they are available at the moment in the market. The EGRBP, it is the tier 3 technology. It is, if there is nothing on it, then tier 4. The 14 lane on the 1st January 2000, then you must apply to tier 3 technology. Thereby, there are the technology that can be introduced with bypass mat. The which is for Tier 3 installations, the EGRs for exhaust gas recirculation, and EGR-TC for engines that 80 diameter. SCR selected catalytic reactor selected reactor. This the high pressure, low pressure depends on the sulfur content that is to be used on the engine. The development, why are we driven to all these changes on designing and introducing the engine? You can see the whole fleet that the environmental requirements and the fuel types and prices. We have seen that with the fuel has been more than expensive, has been shifted to the alternative fuel. So we started back in 1984 with the engine, the fully mechanical engine, and the first super long engine in 1989. The engines which implemented or designed to be large compressors with high speed. This is not the case anymore. Now we have introduced the ME in the electronics since 2003. Then in 2008 we have introduced the ABB. The ABB stands for gas control small. And then in 2013 the ultra long. So this is how it was born. In 2014 we had the first GI means of the first energy produced. The reason we have been doing this in we have been legislating more and more emissions. Of course, some production on the licenses, a safe engine, a reliable engine, and easy. It has been born through the traditional line of engine. The engine program back in 2000 we had 30 engines covering also overlapping, as you can see in the gas power, the for different solutions. Here now we have only 9 engines in the engine program of 2015. In meanwhile, on the engine program of 2000 we have reduced 21. But now we have these are the 5 engines that we have, and what we have done it is to have the layout of engines in order to have more flexibility in the yard and the gas and we have also introduced the fuels, the I, and with the .5 on the engines. From the MC engines, the camshaft container to the engine, and you can see from the we have had the introduction of the ME. To be with you, that a lot of customers the engines, but nowadays with this fuel that we need, that we like can withstand it. Like that, I just said a few slides ago, it is in the new engine program. Our engine program now is 10 engine .5. The layout diagram, that the initial layout diagram, it is with a blue line that it had a specific ppm and a specific mean effective pressure. side of the slide, you see the engine types we have, 9.4, sorry, at the moment it is G. And to the smallest STME, as on the board, we are having the camshaft control engine, which we will explain what we do for it. And these engines have they have MEP, I mean the rate, let's say by 5 to the pressure, and some of them that they have the pressure and the speed. And this is under this shows again also shows the G-type engine really immediately taken almost all the projects at this moment for the tankers, containers, and bulkers. A bit again of the engine program. Like, also nice that you can visualize how it is the engine program when you can either on the internet or by hard copy that it can be. We have, for example, G90, G90, fully electronic, Mark 10, 1.5 bar. Then stainless steel heavy oil train, and then you see the tier. We said keep on NECA areas. So on this fuel oil, each pressures, catalytic reaction, and the engine fuel gas mode, and also now with next slide, tier 3, we also abide with GI engine. GI stands for LNG. Either we apply the high pressure SCR or low pressure SCR. From the type of engine to the immediate the engine has changed parts, design and fit that we always had through continuous development on the engine design, the camshaft control. This proven design has been more than 1 year of design evolution. We, of course, continuously update and design, review the engines, and base this engine development is based on the risks that come and regards the CPS and the here you can see that shows the mechanical differences. So on the left side of the slide, see the lower side, the fuel pumps and the arrangement with the roller type. And then on the MC engine again, see the chain that the camshaft. So on the we have removed the drive, cap is gone, and we have made we have in order to make the fuel and the exhaust valve actuation, we have put a hydraulic supply system of this is the fuel plunger and the exhaust. NCNC, as we said, it's a mechanical engine. The exhaust is operated by a camshaft. By a camshaft. On the MEC, it's an electronic exhaust valve is full injection. So we have an electronic engine control system which is more makes the door not function. In the lubrication control lubricator, it is a lubricator that is used for the lubrication from engine turbo. Hydraulic pumps play for the parts, as we said, auxiliary starting and stopping, start pumps control, start and reversing systems. It is that. Any beer that is just a parenthesis on it, it is a cost. You can friendly in regards to that, and that's why you have seen it the program from the board. The in this case operated by light gas. The fuel system is exactly operated as it is on the MEC engine. Here the engine control system, it is fuel injection, control, governor again function, drone control, lubrication, hydraulic oil pressure control. We will find a little bit later about new features of the MED. We said earlier that the way and the drive, we replace it with pressure. This is 300 parts. This is you will that they take engine lube oil, passing out from and then of course going into the inlet for lubrication. We need 9% and cooling. And then is again to a filter that is going to activate the exhaust pumps and the fuel injection pump. You can see that on the right side of the slide. By drawing the control system is these are electronic components that they are next to the engine. The hydraulic cylinder unit is the one that we have the 300 bar pressure oil awaiting the FIVA valve in order to release or inject or go opening up the high pressure source. These are well driven. Again, we have a change, but more change in order to keep damage of the engine. Something fails, but we have known the service experience that we clocked about the issues. Look, the headlight go on and is looking on top that we pumps again, showing the diagram, the flow diagram, chain drive, the filter, the 6 micrometer and the 25 micrometer for example that you have for from you see the oil lever that are inside the camshaft housing, and it is going into hydraulic units. The electrical starter pumps are pumps that needed only the engine stop. Then you know the electrical in order to raise the pressure of the system to about 170 to 190 bars. And the moment that the engine is turning, immediately the engine drives are going to take recover the supply 300 bar pressure. And next to the cylinder line, as earlier, this is the hydraulic cylinder unit. The fuel, this is the barrel this that it delivers the fuel actuator next to it. The alpha lubricator earlier, the the one the exhaust valve. Then it comes to the hydraulic system. It's no longer existing at installation. This is the proportional valve that we said earlier. The whole that this is the that it stay and the piston not this is now to a low booster unit. The high pressure pipe of the injector to apply inlet. There is an accumulator for taking the high in the system. Again, the feedback valve is operated in order to release the 300 bar. This is as you can see, it's very strong for the group. Let's say taking away the camshaft and the roller guide. There it is for roller bores. You can say friendly from the smaller to take the same electronic sensor. So you don't have this mechanical type pumps. Then you have electronic, yes, that see on the cylinder frame there. Then you have the rail. Here you have a negative. This is fuel injection valve. Because why? We have camshaft to operate exhaust. The booster unit, the same cylinder unit, but of course operated at each time individually in order to give the fuel as edited on the full electronic. So, this is the big block that valve is attached to. For the and country, and also the alpha lubricator that is the one that is delivered in the last. The actuator we said there, the variable exhaust valve. What was the you see on the on the low NBB, the NBB far short exhaust valve on MC engines by increasing the high need ability to release the stage. So low load, the end is open headed as an NBB. On high, we put oil into in the pipe, in the delivery pipe of the oil, then leaving the exhaust valve open, so we have the piston coming upwards from the center without being the component. So in this case, you can control on high loads the combustion and the compression of the engine. This is how it's the type piston earlier from low 50% above allows a little bit of an oil, 300 bar to be timing unit and delay the we had very, very big application of this here. Of course, it was installation costs, it was regardless, because a lot of people are very happy we have had very several systems. NCC cylinder condition. We are now going from dry to open up inspection protocols. Cylinder optimization, very good and very low volume consumption. The incidence of interval just more than 15,000 engines in the market, and flexibility in the program that we said that the engines have been overlapping each other. The good after sales network that we have, and the troubleshooting that we have been advocating. The other point is that we are the adaptive continuous setting of environmental demands. Environmental demands poses big issues, so there is no chance that they can be met anymore by controlled engines. So we have lower specific fuel oil consumption of Tier 2, the DOT 2 and DOT engines, improved operability and monitoring because we have electronics now, improved troubleshooting gas because we can have feedback the engine when an alarm is sounding, what is that rate shaping fuel injection, NOx balancing possibilities, very good on the operating. We measure my online the rest of the engine, and we can do balancing. Also again, which comes to the low load fuel optimization, integrated control added equipment that we have now out by binary certification. What else? Both the and the long this has been coming into the industry because everybody wants very good, let's say, efficiency as EEI figures, CO2 per ton. Also, they have flexibility. So we use the G-type engine, and the G-type engine is an engine that it is you can say more than the type if it is based on the same concept that we have just valve, the MPC, so this is for the electrons, the bearings that we and all design features.